All right. Law of conservation of energy. Does anybody know what this law says? No, you've never heard of it? Okay, this law says energy cannot be created nor destroyed. Yes, energy cannot be created nor destroyed. Energy cannot be created nor destroyed. Energy cannot be created nor destroyed. There will be a question about that on my test, which is Wednesday. And if you cannot answer that question correctly, you will get the privilege of writing energy cannot be created nor destroyed 20 times. That's the only way it can be created. He's the one who made it, and he's the one who gets to say whenever it's not there. But humans don't, like, I can't just make potential energy. It's already there. Yes, you have potential to do something right now. So you have potential energy. And I can't get rid of that, and I can't make you have more. Yeah, when your hand moves, that's kinetic. So while your hand is not writing, it's potential, but then when it does, it is kinetic. And that's explained, really, by this law. Because they just change from one to another. That's exactly what this law is saying. Okay? So before I take you through this picture, I want to show you this. Okay. Little bit about a roller coaster. Majority roller coasters, they start out by some kind of motor taking the roller coaster to the top. Okay, and you don't get to a higher point anywhere else in the roller coaster except at the beginning. Now, yes, there are roller coasters out there that in the middle of their whole little ride, they take you back up again. Right? Do you get what I'm saying? But there's a motor that does that. Mechanical is your potential and kinetic. Yeah, that's confusing, I know.
So it can be both?
No, mechanical is the total potential and kinetic, basically. Mechanical is how they go from one to the other. The way that I always tell my kids to realize mechanical is when something is in motion, that's mechanical energy. Because it had potential, then it went to kinetic, which is mechanical. Does that make sense? Mechanical is a type of energy, like a form of energy, okay? But your main two kinds are potential and kinetic. And everything else can be classified under potential and kinetic. Okay? But mechanical is basically when they go from one to the other. Which is like the water stored behind the dam, and then it goes through and turns a turbine. Turning the turbine is mechanical because it was stored and then it moved, right? Turning the turbine is mechanical, but the turbine turns a generator, and the generator makes electricity. So that's mechanical to electrical.
So mechanical energy because of electrical?
No, mechanical energy because it turns. It rotates. A wind turbine. The windmill turns, and what's in the back of that thing? A generator. So the turning of that rotates the stuff in the generator, and the generator makes electricity. Give me a minute. I'll pull one out. Okay? I got a thing. I'll show it to you. Okay?
Yeah.
You got lost? Okay, I'm going to pull out a thing in a second, if you give me a second, and I'll show it to you. Let's go back to this roller coaster, okay? Basically, what I'm telling you about the roller coaster is electricity's got to pull the darn thing up. Or sometimes they use magnets.
Magnets? I'm never going on a roller coaster ever again.
Why? What do you think? The magnet's going to kill you?
No, because there's a magnet that's pulling the coaster up.
It's an electromagnet.
Oh, so.
It's strong.
They're along the bottom too, don't they?
Yeah.
But they have one that's stronger than the bottom. I've seen a bunch.
Like if you think though about old school roller coasters, wooden, they're scary as could be.
Oh, yeah.
Okay, that is the true idea of potential into kinetic. Because all that like when I was little, there was Astroworld in Houston, and they had that, what was it, the Texas Thunder? Was that what it was? The wooden one was the Texas Thunder? Dude, and I rode that one time, and I never rode it again because I was a scared little kid.
How is it scared? You're on a wooden bus.
Like you can just you can feel it.
Like you feel it swallowing?
Yeah, like it just, the movement of it is, it's not like you being with the harness over you like this and you're just like, you know, it's not the same. It's not the same because the track is not the same either. I don't know, it's just not the same. Anyway, those wooden type of roller coasters, they are true potential kinetic conversions, and that's how you make it through the whole thing. Okay, so I'm going to show you this one. I'm going to do it 2 times, so don't freak out if you miss some of it. The pink is potential, the blue is kinetic. So all that it did the whole time was take the 100% and one blue, pink, blue. Yeah, it just goes back and forth. Okay, so let's do it like step by step. Electricity is going to take it up to the top. Okay, and this is my highest point. So notice that the potential is equal to 100.
That is a lot of potential. Yeah,
Because it's waiting to go down. Exactly. The second that it goes down, I start losing out of that pink circle because I start to gain kinetic, which is motion. Does that make sense? Okay? Yeah. You get it?
Hardly any pink at all.
Yeah, hardly any pink at all.
Only one strip.
Okay? So, that all, I moved the whole way down. At the bottom, my motion was the most motion that I have. Right? Okay, now. I'm starting to go back toward the top, right? So what am I going to start picking up? Potential. Does that make sense? Okay, go to the next part. Okay, it's a lot of potential, but is that the most potential? No, why? But why is it not 100%? Boom! Not at the highest point. This is not as high as that, so it will never be equal. Does that make sense? Okay. The force that keeps me in the loop, centripetal force. That's the force. If you take a bucket, if you fill a bucket up of water and swing that bucket around in a circle, the water ain't going anywhere. Does that make sense? Yes, and you're against the wall.
Oh, yeah, that's good.
You know what I'm talking about? And it looks like this round thing. And you spin, and it holds you like you're like this, and you try to pick your head up, and you're like, yeah, you know why? Because all that it's doing is spinning you in a circle, and the force of keeping you in the circle is called centripetal force. So you're pushed against the wall.
I've been home and I took the
Yeah. Okay, next step. Yeah, and actually, it's not, well, if your lowest point, if that is their lowest point, then it would be all of their kinetic. But really and truly, I think there should be a little bit more potential. It's still on the graph. Yeah, just a tiny bit. Okay, now notice this potential, that potential. Why does number 4 have more potential than number 6? It's higher. Yes. Okay? Right. Let's look at this one. Okay, now. Yes, that's just like a pendulum. All right, so look. When they talk about this stuff, it's neglecting friction. Let me explain what that means. That when we neglect friction, we basically pretend it's not there. Okay? Because in a perfect world, if I put you on something like this and I had no friction, this is what you would do. And you wouldn't stop. Because remember, something in motion is going to stay in motion until an unbalanced force acts on it. Yes, I know you would stop, for real, if I really did this to you, but that's because friction would eventually be your unbalanced force. Okay? Now, we're going to talk about the energy you have. Right? Kinetic and potential are just trading. Does that make sense? This one is thermal. That's heat. But we're playing without friction. Okay? And then the total, what does the law say?
Energy can't be created or destroyed.
So the total doesn't do anything. He has the most potential energy when he's at the highest point.
Yeah.
Eventually, that's the rule. That's the rule for gravitational potential energy. So there it is. Yes. Everybody understand? Okay. Now, let's put it on our paper. This car, what is my kinetic energy? At A, what is my kinetic energy? 0 what? Joules. Okay, so kinetic energy is equal to 0 joules. That is not orange juice or OJ. Okay? I'm going to tell you that right now your potential energy is 50,000 joules. Okay? Everybody cool with that? All right, this cart right here, it's at 60 meters. Do you think, that's what I want you to figure out, which one do you think is higher, potential or kinetic?
Kinetic.
Where do I have the most kinetic energy, did I say? At the lowest point. At the lowest point. So we're only at 60 meters. That's not the lowest point. So potential is still high. Does anybody have a guesstimate of how many?
1,000.
Nope. Think, buddy. We started out with 50,000 and I said potential energy is still high. Nope, that's a little too high. We're at 60 meters. We were at 100. That's right. Good job. 30,000 joules. It's not. It's just because every time I start to move meters, this number is going to go down. They didn't learn any of this the other day. I'm teaching this for the first time. It goes off of what we just did. As soon as I start to go down, this number is going down and this number's going up. Right? You following me? But if this is the most kinetic energy, he just estimated it. I said guesstimate. That's what he did. Now, y'all should be able to tell me how much kinetic is there. 20,000. Who does not understand these two numbers? What was our total?
50,000.
Energy cannot be created nor destroyed. What should this total be?
50,000. It's just separate.
You are exactly right. The potential energy you had is going to the kinetic energy. I said they trade off. Okay? All right, what about the bottom? 10,000 joules of what?
Potential.
It's a little less.
40,000.
Okay, which one's highest? Kinetic. Yes. So down here, our kinetic energy is going to be 42.5. And what does that mean our potential is? Nope. 7,500. Who doesn't understand how we got that? It's 50,000 minus 42.5. Or 42,500 plus what will equal 50,000? Because can this total change? No, not at all. The only way it would change is if I had a new height or a different mass. That's the only way it would change. Yeah. Okay, what about D? What about 36 meters? Do y'all have a guesstimate there? Janie, you got one? What? 20,000 for what? Close. A little less. Nope.
10,000. What did he say?
Which number is supposed to be highest? Kinetic. Very good. That one is 32. $18. And our total, 32 plus 18, is still 50,000 joules. Okay, I know it skips to this letter. We missed it. Her and I didn't. We just totally skipped E, and then we missed it when we made the copies. So, what do y'all think the energy is at F? Why? No, it's not halfway.
That's 40,025.
He is equal to
The PE is 30,000 and the KE is 20,000.
Who just said something about halfway? Somebody said something. You said something about halfway? Okay. So 50 meters would be halfway. What would their energies be at 50 meters? Who doesn't get it?
Oh, okay. I'll keep using personal. Oh, yeah.
Everybody gets it? Everybody gets it.
Is this thing on the test?
Uh-huh.
Like a whole video?
Uh-uh.
One question.
2?
You don't give us questions on our phone?
Nope.
Oh, you have to calculate it?
Yep.
I don't really think how.
What'd you say, Janie?
Sorry, Jamie.
Don't be like that. Don't be like that. Ask me a question. What's giving you trouble? What you thinking about? Or what's making you say that? What's making you freak out like that?
I get the first one, and I get how you get that. I don't know how to get the first number to get the second.
Okay, let me tell you this. I would have to give you some kind of information for you to do these calculations.
Yeah.
Like, you don't, there's a way to calculate it, but you don't have to know all that. So I'm going to have to give you something, kind of like I just did with this. You know what I mean? Like,
You have to give us
yeah, I've already given you other information. The problem's going to be what kids are going to know to go look at their other information and what kids are not. That's going to be the trick. And you know what? The way that they're setting up these LEAP tests, that is what it's all about. They give you tons of information, and it's going to be the kids who go and look into it. I actually made the test off of one of their LEAP things. So, you got to look in the information, okay? Do you understand the concept of the higher it is, the more potential? Okay. And then the lower it is, the more kinetic. And then the other thing is that I can't get any more or less. Yeah. And I mean, I could figure out, I could give you different, heights. What if I started someone at 50 and then said, okay, what would their energy be at 25 or something? I'd have to give you the information. Like, okay, let's say that we had a certain ball and we started him at 50 meters. 50 meters, he has 30,000 joules. What's his energy at 25 meters? 15,000 joules. That's what I'm going to do. Like, because you're applying the law. Yeah. Okay? Okay. What about G? Yeah. No, it's the opposite. Okay, look. I have started over here and used all of my energy to have... Okay, this is kinetic energy equals 50,000 joules. Potential energy equals 0 joules. Yeah, potential energy is going to start over again. But at the very end of it, I've used all this motion to have the total amount at the end. Okay? Okay, one more thing. Mechanical energy. The total energy of motion and position of an object. The total energy of motion and position of an object. The energy of motion is what kind of energy? Kinetic. And what's the energy of position? Potential. Does that make sense? This is actually one of the easier ones, I think. Yeah. I don't have a roller coaster on there. I used something else. Potential and kinetic trade-off. The total mechanical energy stays the same.